Hi, this is Sriyank Siddhartha and welcome to another interesting video on Coroutine. In this one single video, you will explore everything you need to know about coroutines in terms of cancellation, timeouts, and how to handle cancellation exception in a coroutine. So let's get started. Now before you start with this video, there are a few things that you should already know. The first thing that you should know is the basics of coroutine, such as what is a coroutine and how to create a coroutine. Next is you should be familiar with various coroutine builders such as launch, async, and run blocking functions. Well, in the previous two videos, I have already discussed these two things. You can go ahead and watch them if you aren't familiar with them. Fine. Now, the first question that comes to my mind is, why would you cancel a coroutine? Why can't we just let it finish its work for which it was meant to be? Well, there are several reasons for which you would need to cancel the coroutine. There might be a case where you no longer need the result from the coroutine. In that case, you can cancel the coroutine. If the coroutine is taking too long to perform a task, then you can cancel that coroutine and find another way to execute the same task. In short, the reason of cancellation could be anything. So let's explore how to cancel a coroutine. Now, to cancel a coroutine, the coroutine has to be cooperative. So what does this mean? Well, I am going to keep a suspense on what does cooperative mean exactly for next few minutes. So right now, don't worry about this term cooperative. So right now, just remember, to cancel a coroutine, it has to be cooperative. Now, let us take a look at a sample code. Here we have a coroutine, and the code within your coroutine has to be cooperative in order to get cancelled. Please note this. Now, to cancel the coroutine, we need to call cancel function on the job object. So if your coroutine is cooperative, then it will get cancelled. But if your coroutine is not cooperative, then it will not get cancelled and it will continue to operate in the usual manner. And when your coroutine fails to cancel, then this join function will wait for the coroutine to finish. In short, this join function will be effective only when this cancel function fails to cancel the coroutine. So again, please note this. This is very important. So basically, this cancel function and join function are used in conjunction. They are used so often that we have a separate function that combines the property of these two functions. So in place of them, we can use cancel and join function. So when this function is called, then if the coroutine is cooperative, it will get cancelled. Else, if the coroutine is not cooperative, then it will wait for the coroutine to finish. So I hope it makes sense now. Now, it is time to unveil the biggest mystery of this video. What exactly we mean by the term cooperative? What makes a coroutine cooperative? Well, there are basically two ways to make a coroutine cooperative. The first way is to periodically invoke a suspending function that checks for cancellation. And only those suspending functions which belong to KotlinX.coroutines package will make your coroutine cooperative and therefore cancelable. For example, the functions like delay, yield, etc. are the suspending functions which belong to that package. And if you use these functions in your coroutine, then your coroutine will become cooperative and therefore it can be cancelled by calling the cancel function. Feeling confused? So let us see practically how to make our coroutine cooperative by using this step so that you can correlate things all together. So here we have a very simple program using coroutine. Here we are applying run blocking coroutine scope. Then our program starts. We create a non-blocking coroutine by using the launch function. Even you can use the async function over here as per your wish, but I am using the launch function. And this coroutine contains a for loop which prints values from 0 to 500. Then we wait for coroutine to finish, and finally our program ends. So right now our program is very simple. If you run the program now, so it is going to print the values from 0 to 500. I guess I am using 1000 over here, so that's why it is going to print the values from 0 to 1000. So let's make it 500 and run the program again. Okay, so here we go. It prints the values from 0 to 500 like this. And then our program ends. Great. Now let us put some delay while printing values. Let us use thread.sleep function and sleep for 50 milliseconds after each iteration. Well, I am using thread.sleep instead of delay function. It is intentionally just to show you something. Let us run our program again. So now our program print values at interval of 50 milliseconds. So altogether it takes 10 seconds to complete the coroutine, right? But I think as a user, 10 seconds is way too much. So in that case, I would like to cancel the coroutine. So let us terminate my program because I can't wait for 10 long seconds. And here, just before the join function, I will use job.cancel function to cancel my coroutine. But since our coroutine is going to get launched in the background thread, hence it could immediately get cancelled. So let us add a delay function of 200 milliseconds. So this delay function is going to print a few values before the coroutine gets cancelled. Let us run our program. So here our program is running, but there is no signs of cancellation. Our program is running throughout for 10 complete seconds, which means our coroutine did not get cancelled. Right? Now the question arises, why? Well, the reason is at this point of time in our program, our coroutine is not cooperative. Because as per the statements written over here, in our coroutine we are not using any function that belongs to this package. So we have to use either of these functions that belongs to kotlinx.coroutines package, which will make our coroutine cancelable. So right now in our coroutine, we are just using a print function and thread.sleep function. Now these two functions do not belong to this kotlinx.coroutines package. Therefore our coroutine is not cancelable. So even after you call job.cancel, our coroutine continues to work until it finishes its task, right? So let us replace thread.sleep by delay function. And this delay function belongs to this package. And if you look at the documentation of this delay function, then you will find that it says this suspending function is cancelable, and hence it makes our coroutine cancelable. So with each iteration, this function is going to check if our coroutine has got cancelled or not. If it is cancelled, then at a particular iteration, it will cancel the entire coroutine. Fine. So let us run the program and see what happens. So here we go, we printed a few values and then our program ended. Nice and simple. So in this way you can make your coroutine cooperative and therefore cancelable. Now instead of using job.cancel and job.join in two statements, you can use job.cancelAndJoin function, like we saw in our slide. Run the program again, and the output remains the same. Great, isn't it? Now, apart from delay function, we also have other functions like yield function. So in case you don't want your coroutine to delay, then yield function is the best choice for that. Let me show you how to use this function. So instead of delay, let us use yield function. Well, this yield function is cancelable in nature. If you take a look at its documentation, then it says this function is cancelable. Fine. And it also does not delay your coroutine. So either you can use yield function, which is faster than your delay function because it does not delay your coroutine, or you can even use delay function or any other suspending function that belongs to this package as per your requirement. So please note this. Now since we are not using the delay function, so our coroutine won't get delayed, right? And this yield is going to make our coroutine execute very fast. So using delay of 200 is going to print all the numbers from 0 to 500, right? So let us reduce this time to, let's say, 10 milliseconds. Let us run the program. Fantastic, we are printing a few values and our program ends. You can even increase the time to, let's say, 20 or 30 milliseconds in order to print more values. It totally depends on your requirement. So yes, this was all about the first way to make your coroutine cooperative and therefore cancelable. Now moving on, let us check the second way to make our coroutine cooperative. Well, there is a boolean property of isActive, which is an extension on the CoroutineScope class. And this flag can be used to check for cancellation status of the coroutine. So when the coroutine is active, then this flag is true. But when the coroutine is cancelled, then this flag becomes false. So using the false value of the flag, we can terminate the coroutine internally. Now, just for an extra information, in case of threads, we do not have any such flags. We are glad that in case of coroutine, we have got a provision for terminating coroutine based on a boolean value. So this is another advantage of using coroutine in place of threads. Again, please note this. So firstly, let us remove this yield function. The next step would be to check the boolean flag is active. So right within the loop, just before the print statement, we can use if is active, then actually break. Well, I mean to say if the coroutine is not active, then just break out of this for loop and therefore our coroutine will finish. That is, it will terminate automatically. And also within the launch function as a parameter, you need to pass dispatchers.default. Now, this topic of dispatchers we have not explored yet, but we will explore it shortly, don't worry. So let us run the program right now. Well, here we are getting all the values right from 0 to 500. Well, it is not because our coroutine is not cooperative. This is because our coroutine is getting executed very quickly. That is, even before we try to cancel the coroutine, our coroutine is getting executed. So let us add some delay over here. For that, right now I will use thread.sleep function. And let's put a delay of 1 millisecond. Now I can use delay over here, but delay function will automatically make our coroutine cooperative. But we want to test that if this isActive flag is working or not. That's why I am using thread.sleep function. So please don't use this function in your real projects, right? Let us run the program again. So here we go, our program started and we got values right from 0 till, I guess, 73, right? Which means our coroutine executed for a few milliseconds, and then as soon as this function was executed, then this flag isActive became false, which eventually executed this break statement which broke out of the for loop and therefore finished the coroutine, which you can see in the output over here. So this is how we use isActive boolean flag to make our coroutine cooperative. Now, instead of this break statement, you can also use, let's say, return statement, return at the rate launch. So what this return at the rate launch will do, it will return at the coroutine level, that is at this level. So as soon as this statement is executed, no more code within the coroutine will be executed further, which means our coroutine operation is now over and we are returning at this level, therefore terminating the coroutine. Fine. So let us run the program and see what happens. So here we go, we got almost the same output, just that we are printing less number than before. But that's okay, our program executed faster compared to the previous launch. So in this way, by using the isActive boolean flag and by checking it at regular intervals in each iteration, we can make our coroutine cooperative and hence cancelable. Nice and simple. Now that we know two different ways to make our coroutine cooperative, let us now move ahead with the next section of this video and explore how to handle exceptions while cancelling the coroutine. Well, this is yet another important topic related to the coroutine cancellation, so let's explore it as well. Now, when you cancel a coroutine by using suspending functions within it, then cancellation exception is thrown by that suspending function, which you can handle by using try and catch block. In short, all the cancelable suspending functions such as yield, delay, throws cancellation exception when the coroutine is cancelled. So please note this. So here, let me modify the program and use the same program which we saw using the yield function or the delay function earlier. So when you cancel your coroutine, then this delay function, which is actually the suspending function, throws a cancellation exception. So we can wrap our for loop within try catch block. And within the catch block, you can write your code. Great. And just like any other try catch, you can also add a finally block and print something like this. If you run the program now, then our program started and we printed some values, and when we cancel our coroutine, then an exception is thrown, which is caught within this catch block. So we print this statement and then closed resources in the finally block. Right? Perfect. Now moving on, instead of this delay function, you can also use the yield function, or if in case in place of these two functions, if you have any other suspending functions that belongs to this Kotlin x.coroutine package, then that suspending function will also throw cancellation exception. So please note this. Any suspending function that belongs to this package is cancelable and is going to throw this cancellation exception. Fine. Next, you cannot execute a suspending function from the finally block because the coroutine running that code was already cancelled. But in the extreme case, if you really want to execute a suspending function from the finally block, then you can wrap that code within withContext NonCancellable function. So let's see the code in action. So within our finally block, let us put a delay function over here, which is actually a suspending function. And let us run the program. So here you will find that we have caught our exception. But then the finally block was not executed because at this statement, at the statement of delay, another exception was thrown, which resulted in the non-execution of this print statement. So that's why we are not getting the output from the finally block in the output console. Well, we generally don't use suspending functions within the finally block. But in the rare case, if you need to use such functions, then you can wrap your code within withContext function. Like this. And as a parameter, you need to pass non-cancelable companion object. Now, this withContext function is actually a coroutine builder. So this function is going to start a new coroutine in another context, which will execute this suspending function, right? So let us run the program and see what happens. So here we go, we got close resources in finally in the output console. Great, isn't it? Now, moving on, you can also print your own cancellation message by using job.cancel function. And as a parameter, you can pass CancellationException instance and pass your message within the constructor which you want to print. So here within our program, let us split this function into .cancel and then job.join. Once you do it within this cancel function, you can pass CancellationException instance and within the constructor just type your message which you want to print. Like this. And then within the catch block over here, you can print that message by using ex, which is actually the variable we have defined here, dot the message property. Fine. Let us run the program. So here we go, exception caught safely and my own crash message. We are able to print it in the output. How cool is that? So in this way, we actually handle cancellation exception in our coroutine. Perfect. Now that we know how to handle exceptions, let us move on to the next section of this video, that is timeouts. Well, suppose you launch a coroutine that is taking more time than expected to finish its work. Then in that case, you can cancel your coroutine. And for the time-bounded task, Kotlin provides us with special functions, such as the function of withTimeout, and also we have withTimeoutOrNull. Well, these two functions are basically the coroutine builders. That is, just like launch and async functions, they also create coroutines. So let us see how to use them in our program. So here in our program, let us clean up our code, because we are going to write a very simple and clean code. So right here, let us use withTimeout function. And within the lambda expression, let us use a for loop just to perform some task. And as a parameter within the timeout function, you need to pass the time you expect this coroutine to execute and finish its work. Suppose I expect my coroutine to finish my work in 2000 milliseconds, that is 2 seconds. And in case if my coroutine fails to finish the work within this time period, then let's see what happens. For that, let us run the program. So here we go after 2 seconds since our coroutine failed to finish. Then in that case, timeout cancellation exception was thrown, because the timeout function waited for 2000 milliseconds, and thereafter, since our coroutine did not finish, it threw timeout cancellation exception. So just like cancellation exception, you can also handle this exception by using try catch block. You can also add finally block, as per your wish. Now, this timeout cancellation exception is basically a subclass of cancellation exception, which we saw just now in this video, right? So please note this. This class is basically the subclass of the cancellation exception. So moving on, let us explore withTimeoutOrNull function. So if we use withTimeout or null over here and pass 2000 millisecond like this, then the functionality of this function remains the same. This function is going to create a new coroutine. That is, this function is also a coroutine builder. But the difference between withTimeout and withTimeoutOrNull is that this function is not going to throw any exception. So we can remove this try, catch, and finally block. So now, what is the purpose of using this function? Well, this function basically returns some value from the coroutine in the form of lambda result. That is, if you put some value at the end like this, then this value is going to get returned from this coroutine, right? And you can get that value right here, like this. And in case if you put some value such as 15 over here, which is an integer value, then in that case you need to change your data type over here. I think you are aware of this. So let us use the string over here, and then you can use this value result in your program like this. Now also please note that in case if there is a timeout, that is our coroutine is unable to finish the task within 2 seconds, then in that case this result will get the value of null. That is, instead of this string value we will get null over here. So let us run the program and see what happens. So there we go, we got null finally, because there was a timeout. And also remember to make the data type of this variable as nullable type, so that this result can store the nullable object. Perfect. So yes, this was all about timeouts in case of coroutine. So yes, finally we have reached the end of this video. This was a pretty long video, so let us get a big picture of what we learned so far in this video. Initially we learned what makes a coroutine cooperative, that is cancelable. Then we explored two ways to make coroutine cancelable. First, by using the suspending function within the coroutine, such as delay or yield functions. Then second, by using isActive boolean flag. Then moving on, we explored how to handle cancellation exception while cancelling a coroutine by using try, catch, and finally blocks. And along with this, we saw how to use withContext function to execute a suspending function within the finally block. Then we explored the topic of timeouts. And for that we saw withTimeout function as well as withTimeoutOrNull function. And in case of withTimeout function, we also saw how to handle timeout cancellation exception, which is basically a subclass of the cancellation exception. So yes, that is it for this video. So again, what's next? Well, if you want to get a core understanding of coroutine, then you must get a detailed knowledge of what is coroutine scope, what is coroutine context, and what are dispatchers. And trust me, if you want to be a hardcore developer, then having knowledge of these topics is a must for you. And we are going to cover these topics in the next video. So yes, hope you enjoyed watching this video. This is Sriyank Siddhartha signing off. Thanks for watching and have a nice day. Thank you.